Hello dear students, myself Darshana Patel from VPMP Polytechnic. Today I am taking a topic of transposition techniques and steganography of unit number 3, cryptography and public key infrastructure of CNS subject. After watching this video, the students will be able to understand the transposition techniques and steganography. Now, introduction. The video covers topics of transposition technique, that is a rail fence technique, and steganography. Now, first topic, transposition technique. So, what do you mean by the transposition technique and how it's differ from substitutional technique? So, transposition technique is a kind of technique where the plaintext characters or plaintext symbols are rearranged to produce the ciphertext letter. Means we are rearranging we are reordering the letter of plaintext to find the corresponding ciphertext and to encrypt the message. Whereas in case of substitutional technique, we are substituting the plaintext symbol with some other symbols of the ciphertext. Whereas here we are only reordering the characters of the plaintext. Such kind of technique is known as a transposition technique or say transposition cipher. The example of transposition techniques are rail fence cipher, columnar cipher. Now first, rail fence cipher. Rail fence cipher is a type of transposition cipher. It involves rearranging of letters of plaintext to encrypt the message. Means here the ordering of the plaintext letters are interchanged. None of the other extra characters are substituted, but the letters of plaintext are reordered and rearranged to encrypt the message and converting the plaintext to the ciphertext, as well as for converting ciphertext to plaintext. Now consider the example of rail fence cipher. Here our plaintext message is, this is a secret message, and a key value, that is a number of rails, is equals to 3. Now first, for encryption, write the plaintext message in vertical manners. So according to that, we are arranging the message like vertical order. These, T, H, I, then S, this, then is, 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 then this is a secret message, so on. After the ending of the letters, if it requires, then we are filling the extra letters X at the end. Then after writing the message vertically, now we read it horizontally. So after reading the horizontally, we are getting the ciphertext, that is now reading the first row horizontally, that is T as A, C T as G. Then the second row H I S R M S E and so on. So this is our corresponding ciphertext letter. So for encryption, we are writing the plaintext message in vertically and after that read the message horizontally. Now for decryption, we are calculating the total number of letters of the ciphertext. Here our ciphertext message is the TSA, CT, SG and like that. The ciphertext message, it covers total number of letters, that is a 21. Now divide it into 3 groups of letters because our key value, say our number of rails equals to 3. So we are dividing the ciphertext to the letter, number of letters to the key letters or say rail letters. So 21 divided by 3. So now we are dividing our ciphertext message into 3 groups, 7, 7, 7. So each rail, that means for each row we are writing the 7 letters. Now for decryption, we are writing the ciphertext message horizontally like this. The first group we are writing horizontally, TSA, CTSG. Then the second group writing in the horizontally, HIS, RMSE, and so on. Now after writing the ciphertext message horizontally, then read it vertically. It's like a reverse process than the encryption. Now reading it horizontally, reading it vertically, that means our ciphertext letter is, plain text letter is this, 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 then IS is a, SECRET, secret, message, S. So that is our plain text that we are getting through decryption algorithm or railfan cipher. Now next, steganography. Now what do you mean by the steganography? So steganography means hiding a message within another message or image. It is an art of hiding a message, image or file within another message, image or file. Means something we are hiding within another message, or maybe hiding within image or hiding within some file. So how it differs from the cryptography? How the steganography differs from cryptography? So steganography, it hides the fact that something is hiding within message, image or file. In cryptography, we are finding that the something is in the form of encrypted form, but still that thing is not hide. But steganography itself hides the facts that something is hide. Okay. Now the word steganography, it combined the Greek word stagno and graphy. Stagno means covered writing or covered or protected, and graphy means writing. So steganography means covered writing or protected writing. For example, we are hiding the message by writing it within the invisible ink between the visible lines of a private letter. Now these are the various examples of steganography. First, character marking. Means we are writing a big large paragraph or a number of paragraphs and marking that, for example, starting of starting of each statement, by combining such kind of starting of each statement covers some hidden message. So these are the example of character marking. Now invisible ink, we are writing the message with such kind of ink that is not visible, and when we are putting that letter or a page within some particular angle of light, then the thing that is written, that is visible, because it that hidden message, because that kind of message is written through the invisible ink. So that is an example of steganography. Then third, pin puncture. Pin puncture means the paragraph contains a number of characters and a number of statements, and some number of characters, they are pin puncture. They are punctured with the pin, and combining such kind of pin punctured character covers some hidden message. So these are the various examples of steganography. Now digital steganography. It means we can insert data or we can hide data in the image by replacing the bits of image. We are hiding the information within image. For that, the most common techniques are LSB, least significant bits, DCT, discrete cosine transform, and appending method. See the figure. In the first figure, the figure looks like a figure of palace and so on, but it hides the important documents, word document that is hidden with that image that none of the person can know. They seems that it's a photograph of a palace like that, but when the receiver receives that image, that fellow can extract the word document that is hiding information from that image. So that's the example of steganography. Now for that the methods follow. The first method is least significant bits. In this technique, replace the LSB bit with a bit from the hidden data. LSB has the smallest effect on the amount of color. Replacing the LSB to hidden data will have some small effect on the quality of the picture. Means in this technique, the least significant bits of pixels that is replaced with our message that we want to insert, it a little bit degrade the quality of the picture. Then the second method, discrete cosine transform. It works by calculating the frequency of the image, then replace some of them. It's a very strong technique, but it may be little bit complex because it requires the calculation of frequencies of the image. For that, the software that is used, that is a MATLAB. Then third method, appending method. Instead of hiding the data in the photo by manipulating the picture, the appending algorithm, it appends the data to the end of the file as appending. So we are appending the information that we want to hide to the end of the file. So due to that, this algorithm will change the size of the file. Definitely the size of the file may be increased. Thank you for listening.